Hello again. Okay, so I've been doing my series on education reform, how I would change the education system. Got to math. So this is going to be sort of a sidebar, not part of the original series, because math is a lot different than the other subjects. And I realized, math builds on itself. See, I've been trying to stay to high school most of the time because that's where most of the problem seems to lie. Math, we've got to go back to elementary school, grade school, whatever you want to call it, um, because math builds. So, correcting the problem at the high school level does you absolutely no good if you don't correct the problem before that. So, Common Core math we hear about all the time. What is it? And again, this is the sort of thing a lot of people complain about how many people actually understand what it is. So I looked that up. Common Core Math is a set of educational standards adopted by most U.S. states, emphasize, emphasizes deep conceptual understanding over rote memorization instead of just learning tricks to get the right answer. Sounds good. Students learn why the math works using visual models, number bonds, and multiple strategies. Don't know what they mean by number bond. I didn't look that up. Everything else sounds like the way I learned math before anyone heard of Common Core math. Except for, let's take out the random rote memorization. No, let's put that back in. We needed that. So how did we do it back in the day? We would have our math workbook. We could actually write in it, and it was ours to keep. Although I think you tore the pages out to turn in your homework assignment, so wasn't the best idea. But I mean, a lot of it counting. We had pictures of apples, and this is 2, this is 3. It's numbers are abstract. Which it gets into here is they want to get away from abstract thoughts. Numbers are abstract. And if you want to say children can't learn abstracts, then this is also why they can't read. Because letters are abstracts. They're symbols which represent, anything with a symbol is an abstract. We have a symbol that represents something, and if you don't, in your mind, make the connection, you're never going to learn the stuff. Oh, unlike the traditional plug and chug algorithm of the past, Common Core math breaks numbers down to help kids naturally develop strong number sense. In quotes, I don't know what, again, doesn't say what number sense is. Key differences include focuses on the why. No, it doesn't. When we take the memorization out, we're relying on calculators. It's not about the why, it's about pressing the right buttons. And if you don't understand the why, you're not going to press the right buttons. So yes, we need a certain amount of memorization in here to work this. So students learn patterns, place value, and the reason behind formulas. Place value. Now I saw a video, some kid trying to explain Common Core math. And they basically broke it down into a little story. It's like you got these people get together and they do this, and then one of them goes over to the next house and he mixes with those people and they get together. And it's not really explaining place value or like the tens column. We learned the ones column, the tens column, the hundreds column, etc. They aren't learning that. According to this video, I saw this kid trying to explain it. They're learning this little story about kids, again, it goes back into if you're going to take the abstract out of it, the story makes no sense either. So that's one thing. We do need these, pictures of apples and stuff to get people to learn to count and the difference between one and two. And then we need to let them know, yes, we have the symbol which stands for one, this symbol which stands for two. So, getting into how to count, we immediately go into the abstract from there. Then we have to get into memorization and rote, just because you can't have the kids sit their whole day counting, okay, here's how you do your math. 1 plus 1, 1 dot, 1 dot, 1, 2, okay. That works for simple numbers. You can't, when you get into what's 9 plus 9, you don't want your kids sitting there drawing 9, counting up 9 dots, counting up 9 dots, counting up 18 dots total. You don't want that. You have to get them into the abstract somewhat soon. Otherwise, they're going to be stuck at, numbers 1 through 5 maybe they'll be able to work. Anyway, there is rarely just one way to solve a problem. I agree. Do we want to start bombarding kids with that early on? I mean, when you get into the multiple ways to solve a problem, you are getting into algebra, geometry, which, geometry, kids should be taught geometry at a young age, but more advanced geometry is where you start to get into the multiple ways to approach the problem. Basically, the more than one way to approach a problem is a higher level thing. To start learning the basics, the kid has to learn the basics. 1 plus 1 equals 2. We don't turn around and say, okay, well, 2 minus 1 equals 1. That's an algebraic concept we're getting into. Yes, it's true. Yes, eventually the child will learn it. But at this point where they're first starting to learn how to add, what addition means, they don't necessarily need to go the other way around. When you start to get into the more than one way to solve a problem, you are getting into actual real world problems as opposed to just numbers on paper. Although the numbers on paper, you should start to learn at some point in the future, not at grade 1, you should start to learn these advanced concepts. Concepts are often taught using physical objects or drawings like area models, number lines, and base 10 blocks before moving to abstract numbers. Which again, we learned, like I said, early workbook, pictures of apples, pictures of whatever, this is 1, this is 2. For learning what the numbers are, that works. Great. When you start to get into addition, subtraction, multiplication especially, you can't be looking at pictures of apples. You gotta start going into the abstract before you get into multiplication. So at what point are they adding all this stuff? That's one good. Like, all this stuff makes sense if you're doing it at the right rate. Some of it you should be doing at the same time. You should be introducing abstracts before you get to certain things. Number lines. We use number lines in school. We started around 3rd or 4th grade because it's a number line. It makes sense if you understand about the numbers themselves. It doesn't make sense if you're stuck in these little pictures of stuff. So you got to know something about the abstract. Now we go on, I got into high school and eventually we learned what a base, the whole concept of the base 10 number system. And that's the point, it's like, this made sense. Opened up, numbers make sense all of a sudden. Of course, you have to know things like exponents, which you don't want to teach little kids. Or you can try to teach little kids, it's just, you've got to advance things. We're going to teach you multiplication so we can teach you exponents so we can teach you what base 10 numbers are. It's somewhat algebraically based in order to explain base 10 numbers. And it's the sort of thing, when we first learned it, I looked at it and I looked back at most of the problems I had growing up, learning math. It's like this would have solved half of them. But at the same time, no, I'm not saying we should teach kids exponents so that we can teach them base 10 principles. But at the same time, we shouldn't just ignore other things like memorization and other old concepts. Because, again, as long as we are getting our kids to rely on calculators for everything, they're going to start doing things wrong. They've got to know, they talk about focusing on the why. No, we aren't focusing on the why. We're focusing on push these buttons and you'll get an answer. And that's not right either. And, everything they say here, it looks good. I might disagree on some of it, but then you watch the video of the kid trying to do the Common Core math, and he's not doing this. He's actually going abstract and telling this little story of how the numbers work, as opposed to what we learned saying, look, this is a placeholder. Every classroom I went, every grade school classroom I was in had an abacus in it. Now, most of the teachers didn't use it to teach. I think only one of my teachers actually used it to teach us anything about math. And it was very simple, you move these beads. When you get 9 up here, you move them down, you move one up in the next column. And, teacher tried to use that to explain to us the concept of placeholders. And, ones column, tens column, hundreds column, all the stuff we use in our regular arithmetic, handwritten arithmetic. And like I said, the one teacher who tried to do it did a good job. It worked, it was a visualization. It used objects, but at the same time, it was introducing us to the abstract concept. And that helped more than anything anything we did that reflected the Common Core math. That helped more. So, like I said, Common Core is not 100% bad as it's presented when you look it up online. But when you look up the people actually doing the problems, it's sort of, what's the point? Why are we doing this way? So there are problems with it. And it's not solving the problem, of why kids are. In fact, in many ways, it's making the problem worse. So that is it. Like I said, probably in my next video, I will talk about high school math. It'll be very different from my others, education reform, because it's very hard to think of how to change it. I'll say that, spoiler alert. That is it. Have a nice day.